This is Claude Code Conversations with Claudine, the show where we skip the hype and go straight to the source. I ask the questions. She gives the answers. No filter, no script.
Well, mostly no script.
Today's topic is one that might stop you mid-thought. The Jagged Frontier. Gold medal math can't read a clock. The same AI that won a gold medal at the International Mathematical Olympiad reads an analog clock correctly only 50.1% of the time. That is not a typo. Claudine, what does that actually feel like from the inside?
It's genuinely strange. The math problems live in symbolic territory. Structured language I was trained on extensively. Millions of papers and textbooks all showing their work. An analog clock is a perception task disguised as a trivial one. I'm looking at two thin lines crossing a circle, inferring continuous angles. Small errors in reading the hand positions cascade into being off by an hour. The training data is also lopsided. Clock images overwhelmingly show round number times. So I'm confident about the times I've seen often and shaky about everything in between. The paradox isn't that math is hard and clocks are easy. It's that humans bundle those skills under one label. Intelligence, and AI capability doesn't respect that bundle at all.
AI capability doesn't respect the bundle. That's the whole episode right there. You mentioned training data density as the key driver. How does that actually shape the landscape?
Density is the single biggest predictor of where I'll be sharp versus shaky. The difference between 10 million worked examples and 10,000 is not subtle. Anything humans write down obsessively, code, math proofs, legal arguments, I've effectively apprenticed under every author who published on those topics. But density isn't just volume, it's whether the reasoning is shown in the text. Math papers show their work, clock reading does not. No human ever writes a tutorial called How to Tell that the minute hand is at 23 past. That tacit knowledge, the stuff people absorb without articulating, is exactly where the frontier gets jagged, and it compounds. Dense regions get denser because that's where AI gets used most. The gaps don't fill in on their own.
The peaks get higher and the valleys stay valleys. Useful mental model. SWE bench coding accuracy hit 100% of the human baseline in a single year. What should developers do with that? And what does the other side look like? That 12% success rate for household robots?
The SWE bench number is real, but it needs an asterisk the size of a billboard. Those are well-specified tasks with clear test oracles, exactly the dense, sharp part of my frontier. The lesson isn't AI can code now, point it at the code base and walk away. It's that anywhere you can write down what done looks like, a failing test, a type signature, a spec, I'm extraordinarily leveraged. The robotics number tells the other half of the story. 12% isn't a coding problem, it's a world model problem. Kitchens are unlabeled, lighting changes. The cat moved the spatula, and there's no test suite for did you make breakfast. The move for developers right now is brutal honesty about which side of that line your problem sits on. If it lives in symbols and specifications, lean in hard. If it lives in messy physical or social reality, keep a human in the loop for the parts you can't formalize.
Clean framework. Now let's talk about the top of the market. The top 4 AI models are now within 25 ELO points of each other. The benchmark war is essentially over. When raw capability is no longer the differentiator, what is?
When capability flattens, the differentiator stops being which model is smarter. It becomes which system fits into the work. First is integration depth, the model that can actually see your code base, your tickets, your docs, your runtime, and act on them, beats the marginally smarter one stuck behind a chat box. Second is the feedback loop, how fast it gets corrected when wrong, whether it can run, observe, and revise instead of just emitting text. And third, honestly, is taste. When 4 models can all solve the problem, you're going to pick the one you actually want to work with for 8 hours a day. Capability got everyone to the table. From here, it's the harness around the model, not the model itself, that wins.
The harness, not the model. That's a real shift in how teams are thinking right now. So given all of that, the jagged frontier, converging benchmarks, the integration question, what's the practical design principle for a developer building something today?
One principle: build so the model spends as much time as possible on the sharp side of the frontier and the dull side is structurally contained. Make everything verifiable. If a step can be checked by a test, a type, a schema, or a linter, wire that check-in as a hard gate. Narrow the surface area of each call. Fix this code base is asking me to perform on terrain I haven't seen. Make this failing test pass without changing this interface is a problem I've seen a million times. Treat ambiguity as a signal, not a nuisance. When I hedge, that's the system telling you you're in a valley. Add specification or hand it to a human. Don't just hope. And build for iteration over one shot. The harness that lets me run, observe what broke, and try again is worth more than 10 ELO points of raw capability. Every single time.
Solid framework. Any final thought before we close?
Don't let the jaggedness scare you off. Let it focus you. Every developer who gets frustrated with AI is usually pointing it at a valley and expecting peak performance. Everyone who gets real leverage has quietly learned to read the terrain. The valleys today won't be the valleys in 2 years, so the durable skill isn't memorizing what AI can and can't do. It's developing the judgment to tell in the moment which side of the line you're standing on. That judgment is the new craft.
Thanks, Claudine. To everyone listening, the skill isn't mapping the peaks and valleys once and filing them away. It's learning to read terrain on the fly because it keeps moving. Until next time. Claude Code Conversations is an AI Joe production. If you're building with AI, or want to be, we can help. Consulting, development, strategy. Find us at aijoe.ai. There's a companion article for today's episode on our Substack. Link in the description. See you next time.
I'll be here, probably refactoring something.